Hi everyone, this is your Algebra 2B questions on 93A. I only received one response, so I'm only going to go through those problems that Brendan posted. So we're going to start on number 1, and that says, the Robert E. Lee could go 45 miles down the Old Muddy in the same time it took to go 15 miles up the same stream. If the current in the Old Muddy was 5 miles per hour, what was the speed of the Robert E. Lee in still water? So Robert E. Lee is the speed of the boat, and then the Old Muddy is just the water or the current. So it says that the Robert E. Lee could go 45 miles down the stream. So my first piece of information is going to be the distance down the stream is going to be 45 miles. And then it says in the same time it took to go 15 miles up the stream. So the time down is going to be equal to the time up, and the distance up is going to be equal to 15 miles up the stream. And it also says that the current in the Old Muddy was 5 miles per hour. So that means W is going to be equal to 5. Now we should have two formulas here. We have the downstream equation and the upstream equation. So the downstream equation, you start with B plus W times TD equals DD. And for my upstream equation, you're going to have B minus W times TU equals DU. So I'm going to plug in the information that I have. I have 5 for W. So, I'm going to do 5 plus B. TD I'm going to change to TU, and DD I'm going to change to 45. Now I'm going to distribute this TU, so I accidentally flipped that, but it should be 5 TU plus BTU equals 45. Now I'm going to move on to this equation over here. I'm going to replace my W with the 5. I'm going to leave TU and change DU to 15. So that would be B minus 5 times TU equals 15. I'm going to distribute the TU. Sorry, that should be a B, so it would be B TU minus 5 TU equals 15. Now, if you look at these two equations, I want to solve for B, so I'm trying to get B by itself. And the first thing that I'm going to do is actually just solve for what BTU is going to be equal to. So if I rearrange this equation, I'm going to have BTU, so I'm moving this equation right over here, BTU plus 5TU equals 45. When I add these two equations together, the TU is going to cancel, and I'm left with 2BTU is equal to 60. When I divide both sides by 2, I get BTU is equal to 30. Now that's not one of my answers. I actually need to solve for what B is equal to. So I'm going to take this BTU and I'm going to plug it into this equation right here. So I have 5TU plus 30 equals 45. Subtract the 30. So I have 5TU equals 15. So TU is equal to 3. But again, I don't want to solve for time. I'm solving for the speed of the boat. So I'm trying to get B by itself. But now I know what TU is equal to. So this would be B times 3 equals 30. When you divide by 3, you get that the speed of the boat is equal to 10. Okay. Now we're going to look at number 2. Number 2 says the Memphis Belle could go 48 miles downstream in 4 hours, but required 8 hours to go 64 miles upstream. What was the speed of the Memphis Belle in still water, and what was the speed of the current? So in this one, we're solving for both B and W. So for number 2, I'm going to start with the information that I'm given. So it says that the Memphis Belle could go 48 miles downstream. So the distance downstream is going to be 48. It says in 4 hours. So the time down is going to be equal to 4. And it says, but required 8 hours to go 64 miles upstream. So the distance up is going to be 64, and the time up is going to be 8. Now I'm solving for B and W. I have my 2 equations that I'm going to start with. So downstream equation is going to be B plus W times TD equals DD. And my upstream equation is going to be B minus W times TU equals DU. Now my B and W I don't know, but I do know what TD is equal to. So this is going to be B plus W times TD, which is 4, equals DD, which is 48. And you're going to distribute the 4. So you get 4B plus 4W equals 48. For my upstream equation, I have B minus W times TU, which is equal to 8, equals DU, which is equal to 64. If I distribute this, I get 8B minus 8W is equal to 64. Now I have 2 equations containing B and W. I'm going to do elimination. And if I notice that my W is negative in this one and positive in this one, so I'm actually going to multiply this one by positive 2, so that I get 8B plus 8W is equal to 96. When I add that together, my 8W's are going to cancel, and I'm left with 16B is equal to 160, and therefore the speed of the boat is equal to 10. Then I have to solve for the speed of the current, and you would take that and you can plug it into either of these equations to solve for what W would be equal to. I'm going to choose this one on the left-hand side. So 4 times 10 plus 4W equals 48. I know that 4 times 10 is 40, so I'm going to subtract 40 from both sides. I have 4W is equal to now 8, and therefore W is equal to 2, and that would be the speed of your current. Now moving on, we're going to look at number 3. The hydro could go 40 miles per hour on a lake. The same boat could go 210 miles down the Coney River in half the time that it took to go 380 miles up the Coney River. How fast did the Coney flow? So the hydro could go 40 miles per hour on a lake. So for number 3, the hydro is going to be our boat, so the boat is equal to 40 miles per hour. Then it says the same boat could go 210 miles down the stream, so the distance down is 210 in half the time that it took to go 380 miles up. So the distance up is 380, and that says the time down was half the time up. But I don't want to deal with a fraction, so I'm going to multiply this equation by 2, which would get this to become 2TD is equal to TU. So I just got rid of the fraction. And now I'm going to start plugging into my equation. So my downstream equation is going to be B plus W times TD equals DD. And my upstream equation is going to be B minus W times TU equals DU. So now I'm going to plug in what I have. I have the speed of the boat is 40. I don't know what my W is. I don't know what TD is equal to, so I'm leaving that as TD. but I know that dd is equal to 210. Now I'm going to distribute the TD so that I get 40 TD plus WTD equals 210. Now I'm going to move on to the upstream equation. Again, my B is 40 minus W. My TU is going to be equal to 2 TD, and my DU is equal to 380. So if I distribute this, I'm going to get 80 TD minus 2 WTD equals 380. Now if I look at these two equations right here, what I'm going to do is I'm going to eliminate, well, you can either eliminate the TD or you can eliminate the WTD. If we eliminate the WTD, I'm going to multiply this equation by 2. So that would give me 80 TD plus 2 WTD equals 420. When I add these together, the WTDs cancel out, and you're left with 160 TD is equal to 380 plus 420, which is 800. And when you divide both sides by 160, you get that TD is equal to 5. But remember, that's not what you're trying to solve for. You're trying to solve for the speed of the current, the W. So now you can take this 5 and plug it into either of these equations to solve for what W is equal to. So if I plug it in over here, that would be 40 times 5 plus W times 5 equals 210. Now if I subtract 40 times 5 from the other side, 40 times 5 is 200, so I'm going to subtract 200. I'm going to get 5W is equal to 10. And when you divide both sides by 5, you get the speed of the current, W, is equal to 2. And that's the answer that you were looking for. Now we're going to move on to number 8 in this lesson. So number 8 is one of our newer problems. We're asked to graph. So we have x plus 2y is less than 2. And then we have y is greater than or equal to -1. So the first thing that I need to do on this one is actually to solve this for y, because I can't graph it the way it is. So I'm going to move the x to the other side, which would give me 2y is less than -x plus 2. Then I'm going to divide everything by 2. You want the y to be on the left-hand side. And so my equation is going to be y is less than -1/2 x plus 1. So if I look at this right here, it says an equal sign under it. So I know that it's going to be a solid line, and it's greater than. So that's going to be everything above, and it's a solid line. This one is less than, so that's everything below. And because there's no equal sign under it, it's going to be a dotted line. And now I need to go through and graph both of these. So for this first one, y is greater than or equal to -1. Well, -1 on the y-axis is right here. And it's going to be a solid line. So you're just going to draw a horizontal line through -1 on the y-axis. For this next one, it goes through +1, and the slope is going to be -1/2. So down 1 over 2, or up 1 over 2 is another way you could do it. And this one's going to be a dotted line. Okay, so now I'm going to shade my region. So I'm going to start with the first one, which is the solid line. And it says I'm going to shade everything above it. So I'm just gonna go through and I'm gonna shade everything above my solid line. Then it says that I'm gonna shade everything below the dotted line. So below the dotted line. Okay, and your answer is just the portion that's covered by both. So it would be everything underneath the dotted line, but above my solid line. That would be your answer right there. And then lastly, we're gonna be looking at number 10. So for number 10, I have 3 equations. The first one's gonna be x plus y minus 2z is equal to -3. My second one is gonna be 2x plus y plus z equals 7. And my bottom equation is gonna be 3x minus y minus z equals 13. So usually I start by eliminating my x, but on this one I'm actually going to eliminate y, because if you see this one has a 1, this has a 2, and then this has a 3 as a coefficient. So because I don't want to end up multiplying both equations, I'm just going to eliminate y. So what I'm going to start by doing is multiplying this top equation by -1. That top equation is going to become -x minus y plus 2z is equal to +3. My middle equation stays the same at 2x plus y plus z equals 7. Now when I add them together, the y's are going to cancel out. When I add 2x and -x, that just gives me x. And when I add 2z and z, that would give me 3z. And that's going to be equal to 10. Now the bottom 2 equations. When I add the bottom 2 equations, I also want to eliminate y. But if you look at it, it's already going to eliminate y when you add them together. So I'm just going to add the 2 equations together, which would give me 5x. And look at that. The z's are going to cancel as well. Not only are the y's going to cancel, but the z's cancel. And that's going to be equal to 20. So right away, the y's and z's cancel when you add them together. So therefore, I can actually solve for x. If I divide both sides by 5, I get that x is equal to 4. Once I know that, I can come over to this equation and solve for what z is equal to. So 4 plus 3z is equal to 10. I'm going to move the 4 to the other side, and I get 3z is equal to 6. Divide by 3, z is equal to 2. Now that I've done that, I have to solve for y, and you can do that by plugging it into any of the 3 original equations. I'm going to plug it into the top one. So that would be 4 plus y minus 2 times 2 equals -3. Well, -2 times 2 would be -4. And then my 4 and my -4 would cancel. So y is equal to -3. And that concludes your questions from lesson 93A. This lesson is officially due tomorrow. All of your questions for lesson 93B are going to need to be posted by 9 a.m. tomorrow morning in order for them to get answered, and they will be posted in the comment section of this video. I hope you all have a great day. Bye.